Hey class. So welcome to my research presentation. It is uncreatively titled Elevation and Pine Cone Production along the Pajarito Plateau and Jemez Mountains. So ponderosa pines are pretty abundant along the Pajarito Plateau and up in the Jemez Mountains. This is kind of the area in which I live. The range in this area is typically 1,000 feet to 10,000 feet. At least that's what one of the studies proposed, although I couldn't find any ponderosa pines below probably 6,000 feet, I think. Good cone crops occur in the southwest every 3 to 4 years, and while they may produce pollen cones on a more regular basis, seed-producing cones happen intermittently and synchronously in a process called masting. It actually takes 26 to 27 months to produce a cone. This study seeks to examine how elevation impacts cone production for ponderosa pines. Fun note, while the areas I selected to examine, I don't think that there was masting going on. I was up at Sipapoo last weekend, and I caught myself checking out the pine trees and noticing these huge globs of pine cones, and I just kept thinking to myself, I know what's going on here. So that was kind of fun. So starting out, my hypothesis was if ponderosa pines are exposed to warmer weather temperatures at lower elevation, there will be an increase in size and quantity of pine cones produced in those areas. Spoiler alert, that's not completely true. Also, this photo in this slide is a stock photo. I don't know whose dog that is. So let's get into the methodology and how I did all this. So 3 sites were chosen, each at different elevations. At each of these sites, a randomly selected mature tree was identified, and I marked off an area of 20 square feet around the tree. So this was the area that I kind of looked at. All the pine cones within the area were counted, which was tedious. New pine cones were counted within the total while having their own total recorded separately. 20 new pine cones were randomly selected from within that area, and I took height measurements and measured their circumference. I took temperature recordings 5 different times over the course of this research project. The measurements for the selected pine cones were recorded and analyzed to determine the range and mean. Additional observations about the cones were also recorded. And then I took all of this and kind of compared them across all 3 sites. Okay, so at site 1, this was the lower elevation site. It was around 6,325 feet. So this one didn't actually have any new pine cone production. In that 20 square foot area, there was about 211 cones total. So this one didn't have any new cones, but I went ahead and measured some of the old ones. So height measurements, the range was from 1.75 inches to 3.875 inches, and the mean came out to about 3.35 inches. For circumference, the range was 5.12 inches to 8.25 inches, and the mean came out to about 7.3. The temperatures I recorded at this area were 54 degrees, 48 degrees, 44 degrees, 39, and 26 degrees. So site 2 had an elevation of about 7,408 feet. There were quite a few new cones in this area. Total cones counted came out to 249, 36 of those being new. The height range was 2.5 inches to 4 inches, and the mean came out to about 2.79 inches. Circumference range was 6.875 inches to 8.25 inches. The mean came out to about 6.9. Temperatures recorded 56 degrees, 49 degrees, 48 degrees, 42 degrees, and 30 degrees. Site 3 was way up in the Jemez, around 8,600 feet. There was a higher number of new cones compared to Site 2. So total was 263 cones counted in the area, with 87 of those being new. Height range was 2 inches to 3.5 inches. The mean came out to about 2.84. The circumference range, 6.125 inches to 8.25 inches. Mean came out to what, 6.86 inches. Temperatures recorded up here. This was kind of close to Camp May, so 51 degrees, 45, 38, 31, and 29 degrees. So a little chart comparison. So while the measurements, the mean for both height and circumference were lower at were greater at lower elevations, there are actually no new cones down there. Measurements for Site 2 and Site 3 were similar, but cone production was highest at Site 3. So additional observations. This is kind of where it was interesting. I should have put this in the text, but the cone on the left in this picture is actually from Site 2, and the cone on the right is from Site 3. So I noticed the cones at Site 2 had more symmetry. They kind of had a brighter color, tighter pattern of cone, and were kind of larger overall. So the result, so while the size of cones were larger at lower elevations, as in my hypothesis, new cone production was reduced. In fact, new cone production was highest at highest elevations. An article out of the Nature Conservatory kind of notes how, moisture definitely plays a part in pine cone production, but the moisture, it depends on the elevation, kind of like what I was looking at. But it does note that lower elevations with hotter and drier conditions that receive summer rains are more significant for cone production, and that this kind of diminishes with elevation, although it kind of appeared the opposite in my study. I think it's hard to kind of do this in such a short period of time, given how long it takes to produce cones. So if I were going to really get into this, this would probably be a long-term observation. So the intermediate range appeared to produce healthier cones. This might be due to the distance between the trees in the intermediate level. A 2009 study kind of found that tree proximity, there was a big correlation between that and cone production, just because of the ability to pollinate. And so the trees at the lowest elevation were fairly isolated, and the trees at the highest elevation, while there were definitely more around, there weren't many of them, but in the intermediate range they were pretty close together. So up at the higher elevations, just because there is more snowpack up there and they have a kind of more continuous access to moisture, that may contribute to the higher number of new cones. The temperature recordings were several. Oh, so when comparing the temperature recordings I took now to the annual averages, they were actually several degrees cooler. And so this kind of made me think about how temperature might affect cone development, at least in terms of, how healthy they are, kind of their shape, their size. Although the trees at the higher elevation may have just been what's kind of referred to as super trees, that just typically produce more cones altogether. A study out of Colorado kind of pointed out how of all the trees they observed, 12% of them was what they called super trees and just produced more cones on average altogether. So discussions. Several factors were definitely not accounted for during the study, one being infestation and disease. I didn't really kind of look at how, you know, cone moths or cone beetles or any kind of other bugs may have impacted their production. The effects of wildlife in the area, whether wildlife is kind of dispersing cones or anything like that. Also, the effect of burn zones and forest management. So the site at the highest elevation were part of the Cerro Grande fire that occurred in 2000. And while it happened over 20 years ago, it may be possible that the area is still being impacted some way. Also, forest management coming through and having an effect on cone production, kind of shape, size, healthiness of the cones. But yeah, so that's kind of what I was looking at. It actually got me more interested in the trees in the area. So these are some of the references that I used. And I wanted to say thank you. All pine cones have since been returned to the wild, except for one unfortunate cone that was chewed up by our dog. And so this presentation is dedicated to this cone.